Yes, now this is another important question. It is A, B minus C, C plus B, A plus C, B, C minus A minus B, B plus C, C. We have to prove as A plus B plus C, A square plus B square plus C square. Now, whenever this question comes, this is also not giving very much hint to us. So we should start with one condition. We will multiply this row or column, sorry, column 1 we will multiply with A. When you do this, it will come 1 by A. It will be A square plus AC, A square minus AB. This is left B minus C, B plus C, then B plus C, C minus A and C. Okay, this is very important result. This is another question in which if you have done it once, you can do it, otherwise again a problem will come for you. So in this case, now the second step is also very important. On C1, we will take C1 plus, this I'll multiply with B, C2, and then plus C times of C3. This I multiply with B, this I multiply with C, and I add this here. When you do this, you will get A square plus B square plus C square. Just check what it comes. 1 by A is already here. Here it is A square plus, what it will be, B times of this. So B times B minus C, and then C times this, C times B plus C. Same way here, A square plus AC, then B times of C2. So it's plus of B square, and then C times of C minus A. Then third one is A square minus AB plus B times of B plus C, and then plus of C square. B minus C, B plus C, B, C minus A, B plus C and C. Now how it will help, just check. It will become A square plus B square minus BC plus BC plus of C square. A square plus AC plus B square plus C square minus AC. A square minus AB plus B square plus BC plus C square. Something wrong. This BC get cancel out, this AC get cancel out. Here something wrong we are doing. B square plus BC. A square minus, it is AB or BC, what it was? Third row. Third row is slight problem here. I'll just check the question. A plus C, A minus B. A minus B. So it is B square plus BC. It should come BC. A plus C. A square, yes. A square minus AB. This is wrong here. This should be B plus A. Correct in the question, it is B plus A. So when it is B plus A, so it will be B square plus AB will come. And then it is B minus C, B, B plus A. Then B plus C, C minus A and C. When you do this, this get cancelled out. Every term is now A square plus B square plus C square. So 1 by A, it will be A square plus B square plus C square, A square plus B square plus C square, A square plus B square plus C square. B minus C, B plus C, B, C minus A, B plus A and C. And then A square plus B square plus C square will be common in all. We will take common as A square plus B square plus C square. When you take common, it will come 1, 1, 1. This will be B minus C, B plus C, B, C minus A, and then B plus A, and this is C. And then now you can proceed this question, two zeros you bring and solve it. So this question you can complete yourself. So this is an important result. First and second result was very important, which I told you. Next, a very important question now. Next question says that if you have any skew symmetric matrix, this is also theorem we can see, any skew symmetric matrix with odd order has determinant value is always 0. This we have to show. Any skew symmetric matrix, if you have skew symmetric matrix, I told you A is equal to minus of A transpose. So whenever A is equal to minus of A transpose, then if you take the determinant of it, that determinant always give you result 0. I'll prove that also. Let A is a square matrix, Aij order n into n, where n is odd. And one more information given, it is a skew symmetric matrix. A is equal to minus of A transpose. We are concerned about the determinant of A now. So if these matrices are same, their determinant is also same. Determinant A is minus of A transpose determinant. Now, if you take minus out from this determinant, how many minus will go out? Very important result. By the way, if it is a matrix of 3 by 3, one thing I told, if it is a matrix minus, if you multiply, you can multiply with each and every element. But now it is becoming a determinant. So when it is a determinant, if you take common out, should be taken row wise or column wise. How many rows will be there? N rows will be there. So we will take how many commons? Minus 1 power n. And then left is A transpose. Okay, minus 1 whole power n, determinant of A transpose. And n is an odd number, so it shows it is minus of determinant A is coming equal to determinant A. And when you solve it, it will come twice of determinant A is coming 0. And if twice of determinant A is 0, we will say determinant A coming 0. So this is the question, or we can say theorem. Any skew symmetric matrix with odd order always give determinant value 0. I'll take an example, then it will be more clear. Because this step maybe you feel slight difficult. So I'll take that one example here. 0 A minus B minus A 0, and this come out to be B. Then this element is minus C, C and 0. This is one determinant A. Okay, or you say this is one matrix first. You can take this as matrix. And one thing is clear in this matrix, we have matrix A is equal to A transpose minus. A is equal to minus of A transpose, I am going to get or no. So that means it is a skew symmetric matrix. Why? Because this element and this element differ by minus, these two elements differ by minus, these two differ by a minus. A is the matrix here. So A is equal to minus A transpose we have. Now what I do here, I'll start with determinant A. That is 0, A minus B, minus A, 0, minus C, B, C and 0. This is determinant. Now I'll take common. Minus common from here, minus common from here, minus common from here. How many common will be there? Minus 1 power 3. Whatever the order, that will be minus coming common here. So left is 0, minus A B, A 0, C, then minus B, minus C and 0. Is this clear? You're getting this result? And now, this determinant A will be minus and this will be 0 minus AB, A0 C, minus B minus C and 0. Is it right? And now, we have already done determinant A is determinant of A transpose. So if you take this transpose, minus remain as it is, you take transpose 0A minus B, minus A 0 minus C, B, C and 0. Is it right? Is it your matrix A, determinant A? Yes. So what this will come out to be? Minus of determinant A. That means we will get determinant A come out to be minus of determinant A, or I should say twice of determinant A is coming 0. That indicates determinant A is coming 0. So whenever you have a determinant with odd order, matrix with odd order, and it should be a skew symmetric matrix. Just check here. We got one matrix 3 by 3. It was symmetric also, skew symmetric, and its order is odd. Then what you got? A determinant is coming 0. So determinant A come out to be 0 whenever we have a matrix with odd order. Its determinant value always come out to be 0. So that you should keep in mind. So this is the matrix part we have finished. In next class, I'll be starting with new topic, and that new topic will be limits. That is the continuity portion we have to start. Or you say then relation can be done, but I think limits you have done. So we should start with the limit. So next topic we will be starting second chapter. We are starting with limits. Relation function we'll do later on. So first we will be starting with relation function, and then we'll continue with that. Okay. So limits and derivatives we are starting. Clear? So that you should keep in mind. Okay, next class. Don't miss first class, because that will be important for limits here. Because limits you have done, so simply I'll revise that, and after that we'll go on the continuity. That is the next chapter we have next time. Thank you.